Hello students, myself Sarama Malik, Assistant Professor of Gargi Memorial Institute of Technology. In my previous lecture, I discussed about the transformation of double integrals, and in today's lecture, I discuss about the application of double integrals. Now, double integrals have various type of geometrical and physical application. Okay, and it is used to find the area of a plane region, the volume bounded by a surface and a plane. It is also used to find the center of mass, center of gravity, and the moment of inertia. Okay, so today I discuss about all of this. Double integral have various geometrical and physical application. It is used to find the area of a plane region, volume of a surface and a plane, it is also used to find center of mass, center of gravity, and as well as moment of inertia. Okay, so first the area of a region R in the xy plane is given by the double region double integral, say that is capital A is equals to double integration over the region R dx dy. Okay, the double integral of f of xy f of xy on R is denoted by xy dx dy. Okay, it represents the volume V of the surface z is equals to f of xy and the region R in the xy plane volume V bounded by surface and the region R in the xy plane is V is equals to double integration over the region R f of xy dx dy. Okay, so next we find the total mass. Okay, now when f of xy denotes the density, that means mass per unit area of a distribution of mass in the xy plane, then the total mass m in R is given by double integration over the region R f of xy dx dy. Okay, and let x bar y bar be the coordinate of the center of gravity of a mass distribution in the xy plane, then x bar is equals to double integration over the region R x into f of xy dx dy by double integration over the region R f of xy dx dy. This value is equivalent to m, so this x bar is written as 1 by m into double integration over the region R x into f of xy dx dy, and y bar is equals to 1 by m double integration over the region R y into f of xy dx dy. So these are the all formulas. Now we illustrate some examples here. A plane lamina of non-uniform density is in the form of a quadrant of the ellipse x square by a square plus y square by b square is equals to 1, and if the density at any point xy be k of k into xy, where k is constant, then find the center of gravity of the lamina. Okay, so this is our question. we have to find out here the center of gravity. First we draw the picture. So this is our ellipse. Okay. Now here let x bar y bar be the coordinate of the center of gravity of the portion OABO of the ellipse x square by a square plus y square by b square is equals to 1. Okay. So x bar is equals to integration of 0 to a. Here x vary from 0 to a, and y varies from this 0 less than is equals to y less than is equals to b into root over 1 minus x square by a square. Okay, so integration from 0 to a and 0 to b into root over of 1 minus x square by a square kxy dx dy into x by integration of 0 to a 0 to b into root over of 1 minus x square by a square kxy dx dy. Okay, this is the value of x bar. And next y bar is equals to integration of 0 to a integration of 0 to b into root over of 1 minus x square by a square kxy dx dy into y by integration of 0 to a 0 to b into root over of 1 minus x square by a square kxy dx dy. This is equation number 2. Okay, so from 1 and 2 we have to find out x bar and y bar. Now the numerator of 1 and 2 numerator of 1, this is equals to integration of 0 to a 0 to b into root over of 1 minus x square by a square k into x square y dx dy. Okay, this is equivalent to k into integration of 0 to a x square, integration of y is y square by 2, 0 to b into root over 1 minus x square by a square dx, sorry, only dx. So that is equals to half of k into integration of 0 to a x square into b square into 1 minus x square by a square dx, that is equals to half into k into b square by a square, integration of 0 to a x square into a square minus x square dx, which is equals to kb square by 2a square into a square into x cube by 3 minus x to the power 5 by 5, 0 to a. After putting the values of the integration, so this value will be k into b square by 2a square into a to the power 5 by 3 minus a to the power 5 by 5, that is equals to k by 15 into b square into a cube. Okay, so numerator of 2, which is equals to 0 to a integration of 0 to b into root over of 1 minus x square by a square k into x y square dx dy. Okay, so this is integration k into integration of 0 to a x, and after integration of y, this will be y cube by 3, 0 to b into root over of 1 minus x square by a square dx. So this is k by 3 integration of 0 to a x into y cube, that is this b cube into 1 minus x square by a square whole to the power of 3 by 2. This is dx. That means k by kb cube by 3a square integration of 0 to a x into, sorry, 3a cube, this will be x into 1 a square minus x square whole to the power of 3 by 2 dx. Okay, now if we let here a square minus x square is equals to t square, so minus 2x dx, this is equals to 2t dt. And the limit of x will be changed here. When you put here x equals to a, this will change 0, and if we put here x equal to 0, this will be t, this will be a, sorry, this is a to 0. In place of x we put here a square minus t square, and this will be t cube into x dx तो x dx का वैल्यू 2t into dt, so this is minus t into dt. Okay, so it is k b cube by 3a cube minus integration of a to 0 t to the power 4 dt. That means minus k b cube by 3a cube t to the power 5 by 5 a to 0. So minus k b cube by 3a cube into minus of a to the power 5 by 5. That means k into b cube is square by 15. Okay, so and the denominator of 1 and 2, which is equals to k into integration of 0 to a 0 to b into root over of 1 minus x square by a square xy dx dy, that is equals to k into integration of 0 to a x into integration of y is y square by 2 0 to b into root over of 1 minus x square by a square. Okay, so that is k into k by 2 into integration of 0 to a x into b square into 1 minus x square by a square dx, that is equals to k b square by 2 a square into integration of 0 to a x into a square minus x square dx, that is k into b square by 2a square, integration is a square into x square by 2 minus x cube x to the power 4 by 4 0 to a, k b square by 2a square into a to the power 4 by 2 minus a to the power 4 by 4, which is equals to k into a square b square by 8. So x bar is equals to 8 by 15 k by 15 into b square into a cube by k square b square by 8, that is 8 by 15 into a. Okay, and y bar is equals to k by 15 into b cube a square by k square b square by 8, that is 8 by 15 into b. Okay, so x bar is equals to this and y bar is equals to this. That means So the required center of gravity is at 8 by 15 into A and 8 by 15 into B. Okay. And another example is, find the center of gravity of the region bounded by the parabolic cylinder z is equals to 4 minus x square. The coordinate planes and y is equals to 6. Okay. Now to solve this, first we draw the picture as it is a parabolic cylinder. So this type. Okay, this is our bounded region. This is y is equals to 6 and z is equals to 0. And this is x equals to 2, z is equals to 0. Okay, so let x bar, y bar, z bar be the coordinate of the center of gravity. This is centroid hobe. This is centroid of the region. Okay, region D, which is shown in the figure. Okay, and also let rho be the uniform density of the region D. Okay, so x bar is equals to integration of 0 to 2, x equals to 0 to 2, y vary from 0 to 6 and z vary from 0 to 4 minus x square rho x dx dy dz by x equals to integration x equals to 0 to 2, integration y is equals to 0 to 6 and integration z is equals to 0 to 4 minus x square rho dx dy dz. Okay, this is the value of x bar. Now y bar is equals to, this is also same, x equals to 0 to 2, integration y is equals to 0 to 6 and integration z is equals to 0 to 4 minus x square rho y dx dy dz by integration of x equal to 0 to 2, integration y is equals to 0 to 6, integration z is equals to 0 to 4 minus x square rho dx dy dz and z bar is equals to integration x equals to 0 to 2, y is equals to 0 to 6, z is equals to 0 to 4 minus x square, rho z dx dy dz, and x equals to 0 to 2, y is equals to 0 to 6, z is equals to 0 to 4 minus x square, rho dx dy dz. Okay, so this is equation number 1, this is 2, and this is 3. Now so first we have to find out the denominator of 1, 2 and 3 is x equals to 0 to 2, y is equals to 0 to 6, and integration of z is equals to 0 to 4 minus x square, rho dx dy dz, that is equals to rho into integration of x equals to 0 to 2 and y is equals to 0 to 6. This is 4 minus x square dx dy. So rho into integration of 0 to 2 4 minus x square dx and integration of 0 to 6 dy, they are different, so we integrate both. This will be 4x minus x cube by 3 0 to 2, and this is only y 0 to 6, that is equals to 2 rho into 8 minus 8 by 3 into 6, that is 16 by 3 into 6, so 32 into rho. Okay, so and the numerator of 1, that is integration of x equals to integration of 0 to 2, y is equals to 0 to 6, and z is equals to 0 to 4 minus x square, rho x dx dy dz, which is equals to rho into 4 minus x square into x dx dy. Okay, so this will be rho into integration of 0 to 2 4x minus x cube dx and 0 to 6 dy, that is equals to rho into this is 2x square minus x to the power 4 by 4 0 to 2 into y 0 to 6. So rho into 8 minus 2 to the power 4 is 16 by 4 into 6. 4 into 6, that is 24 into rho. Okay. Numerator of 2, this is integration x equals to 0 to 2, y is equals to 0 to 6, integration z is equals to 0 to 4 minus x square rho y dx dy dz, that is equals to rho, this is 4 minus x square into y dx dy. Okay, so rho into integration of x equals to 0 to 2 4 minus x square dx into y is equals to 0 to 6 y dy. Okay, so that is equals to rho into 4 minus x square, that is 4x minus x cube by 3 0 to 2 and y square by 2 0 to 6. So it will be rho into 8 minus 8 by 3 into 36 by 2, that is equals to rho into 16 by 3 into 36 by 2 is 96 into rho, and the numerator of 3, this is equals to, sorry, x equals to integration x equals to 0 to 2, y is equals to 0 to 6 and integration z is equals to 0 to 4 minus x square rho into z dx dy dz, that is equal to rho into integration of x equals to 0 to 2 and y is equals to 0 to 6 z square by 2 0 to 4 minus x square dx dy, that is equals to rho into, sorry, rho by 2 into integration of x equals to 0 to 2 4 minus x square whole square dx and y is equals to 0 to 6 dy, that is rho by 2 x equals to 0 to 2, this is 16 minus 8x square plus x to the power 4 dx and it is y 0 to 6. So it is rho by 2 into 6 and integration of this is 16x minus 8x cube by 3 plus x to the power 5 by 5 0 to 2. So that is equals to 3 rho into 32 minus 64 by 3 plus 32 by 5, which is equals to 256 into rho by 5. Okay, so that means from 1, 2 and 3 x bar is equals to 24 rho by 32 rho, that is equals to 3 by 4. Okay, and y bar is equals to 96 rho by 32 rho, that is equals to 3, and z bar is equals to 256 rho by 5 into 1 by 32 rho, that is equals to 8 by 5. Okay, so the required centroid is 3 by 4, 3 and 8 by 5. Here